Good morning to one and all present over here. Myself, L.ANBARASU, Associate Professor in the Department of EEE. Today's session, we are going to see about the various objective type questions for the electrical machines. So in this video, mostly preparation for the GATE coaching class for SC/ST students. It's under the AICTE PRERANA scheme. The subject name electrical machines, session name DC motors and transformer objective type questions. So first we discussed about the DC motors objective type questions. Here first question number 1. In a DC motor, unidirectional torque is produced with gulp of. In a DC motor, unidirectional torque is produced with gulp of. There are four options are there. A, presses. Option B, commutator. Option C, end blades. Option D, both A and B. So there 4 options are there. Correct answer is both A and B. Okay, is the correct answer. So because by means of with the help of commutator and brushes, the unidirectional torque is produced in case of DC motor. The correct answer is both A and B. The second question, the counter EMF. So counter EMF means back EMF. The counter EMF of a DC motor. The counter EMF of a DC motor. Option A, often exceeds the supply voltage, aids the applied voltage, helps in energy conversion. Option D, regulates its armature voltage. Definitely it cannot exceed the supply voltage. So option A is not correct answer, and also aids the applied voltage is also not correct answer. It helps in energy conversion process. So it is the exactly correct answer for the question. The counter EMF or back EMF of a DC motor, it is used to help the energy conversion process, because in case of DC motor, it converts the electrical power into mechanical power. The back EMF is the one of the energy conversion process. Okay. So fourth option, it is not correct answer. So exact correct answer is it helps in energy conversion. Okay. This is the correct answer for question number 2. Next question number 3. The normal value of the armature resistance of a DC motor. The normal value of the armature resistance of a DC motor is. So option A 0.005, option B 0.5, option C 10, option D 100. So option D 100, it is highest value. Highest value of resistance means to produce a more voltage drop. So option D 100 ohm is not correct answer, and also option C 10 ohm also not correct answer, because 10 ohm are also to produce a more voltage drop. So 0.005 ohm, it is a very low resistance. So it cannot produce in the field winding, armature winding resistance. So armature A, option A, it is not correct answer. So exact answer is it is resistance lies in between the 0.5 ohm to 1 ohm. So option B is the correct answer for question number 3. So question number 4. The ratio, the EB divided by voltage ratio of a DC motor is an indication of its, the EB means back EMF divided by voltage ratio of a DC motor is an indication of its. So definitely it is an efficiency. It is not related to the speed regulation. It is not related to the starting torque. It is not related to the running torque also. So it is related to the efficiency. So efficiency, it is nothing but output power divided by input power. So voltage, it is an input power. EB back EM, it is an output power. So it is related to the efficiency. The option A, efficiency, is correct answer. Okay, next question. Question number 5. The mechanical power developed by the armature of a DC motor is equal to. The mechanical power developed by the armature of a DC motor is equal to. The mechanical power developed by the armature of a DC motor is equal to option A, armature current multiplied by back EMF, power input minus losses, power output multiplied by efficiency, power output plus iron losses. The last three answers are not correct answer, because power input minus losses, it is not correct answer. Power output multiplied by efficiency, the efficiency not multiplied by the power output, it is not correct answer. Power output plus iron losses are also not correct answer. So exact answer is armature current multiplied by back EMF. So EB into IA. So already we know that power developed by the armature PA equal to EB into IA. That is the formula behind this question. So option A is the correct answer for this question number 5. Next question number 6. The induced EMF in the armature conductors of a DC motor is. The induced EMF in the armature conductors of a DC motor is. There are 4 options are there. Option A, sinusoidal. Option B, trapezoidal. Option C, rectangular. Option D, alternating. The induced EMF in the armature conductors of a DC motor is. So definitely it is a sinusoidal. In case of DC motor, the armature winding, the current flow through armature winding is an AC current, okay, alternating current. The commutator and the brushes, it is used to convert the unidirectional EMF. The direct EMF is converted into unidirectional EMF is converted into alternating EMF in the armature winding. The exact correct answer is sinusoidal EMF. Okay. So question number 6. Option A is correct answer. Question number 7. A DC motor can be looked upon as DC generator with the power flow. A DC motor can be looked upon as DC generator with the power flow. Option A, reduced. Option B, reversed. Option C, increased. Option D, modified. Of course, DC motor can be looked upon a DC generator. The power direction is reversed. Okay. The electrical machine act as a DC motor means the power flow direction is one of the direction. Same machine act as a DC generator means the power flow direction is reversed in previous case. So that is the option B is correct answer. Question number 8. In a DC motor, the mechanical output power actually comes from. In a DC motor, the mechanical output power actually comes from field system, air gap flux, back EMF. Last one is electrical input power. In case of DC motor means it converts the electrical power into mechanical power. So that means electrical power is converted into mechanical power. So exact correct answer is D. Option D, electrical input power. So next question number 9. The maximum torque of DC motor is limited by. The maximum torque of DC motor is limited by option A commutation, option B heating, option C speed, option D armature current. So question number 9. The maximum torque of DC motor is limited by commutation, heating, speed and armature. The maximum torque of DC motor is limited by commutation. So commutation is correct answer. Option A commutation is correct answer. The next one, 10th question. Which of the following quantity maintains the same direction, whether a DC machine runs as a generator or as a motor? Which of the following quantity maintains the same direction, whether a DC machine runs as a generator or as a motor? Suppose it is an engaged EMF. In case of DC generator, it can be denoted as EG. In case of DC motor, it is denoted as EB, back EMF. So back EMF, so that is the induced EMF is one of the quantity. It maintains the same direction, act as a generator or act as a motor. Question number 11. Under constant load conditions, the speed of a DC motor is affected by. Under constant load conditions, the speed of a DC motor is affected by. Option A field flux, option B armature current, option C back EMF, option D both B and C. Armature current and back EMF. The question number 11. Under constant load condition, the speed of a DC motor is affected by. The exact answer is field flux. The N directly proportional to EB divided by flux pi. It is inversely proportional to field flux. So it is one of the parameters. It is used to change the speed of the motor. So field flux is the correct answer. Question number 11. So next question, 12th question. It is possible to increase the field flux. It is possible to increase the field flux and at the same time increase the speed of a DC motor provided its dash is held constant. Option A applied voltage, option B torque, option C armature circuit resistance, option D armature current. It is possible to increase the field flux. So we can increase the field flux means we can maintain the armature parameters. So armature parameters is one of the parameters is armature current. The armature current is the correct answer in question number 12. We can maintain the armature current kept at constant. We can vary the field flux. Question number 13. The current drawn by a 120 voltage DC motor of a armature resistance 0.5 ohm and back EMF 110 voltage is dash ampere. The current drawn by the 120 voltage DC motor of armature circuit resistance of 0.5 ohm and back EMF 110 voltage is dash ampere. So option A 20, option B 240, option C 220, option D 5. You can utilize for the formula EB equal to V minus IA into RA. By using this formula, we can determine the armature current value. The exact answer is 20 ampere. Option A, 20 ampere. Question number 14. The shaft torque of a DC motor is less than its armature torque. The shaft torque of a DC motor is less than its armature torque because of dash losses. The shaft torque of a DC motor is less than its armature torque because of its dash losses. Copper losses or mechanical losses or iron losses or rotational losses. The copper losses, it depends upon the current. Mechanical losses, it is the combined losses of friction and rotation losses. Iron losses, it is only the iron particles only. The torque, shaft torque and the armature torque, it is only related to the rotational. So torque, which means it is a turning or twisting moment of force. So the correct answer is option D. Option D, rotational losses. Okay. So next question number 15. A DC motor develops a torque of 200 Newton meter at 25 RPS. RPS means revolution per second. At 20 RPS, it will develop a torque of. At 20 RPS, it will develop a torque of dash Newton meter. A DC motor develops a torque of 200 Newton meter at 25 RPS. At 20 RPS, it will develop a torque of option A 200, option B 160, option C 250, option D 128. Same 200 Newton meter is the correct answer. The torque produced in that motor cannot be changed in case of changing the speed. Okay. The next question number 16. Neglecting saturation. If current taken by a series motor is increased from 10 ampere to 12 ampere, the percentage increase in its torque is dash percentage. The percentage increase in its torque is dash percentage. So it is the correct answer is B 44%. We can increase the 10 ampere to 12 ampere means the torque developed in the DC series motor is increased to 44%. In case of DC series motor, the current value can be increased means automatically the percentage of efficiency increased. Okay, question number 17. If a load of a DC shunt motor is increased, if load on a DC shunt motor is increased, its speed is decreased due to primarily to. Its speed is decreased due to option A, increase in its flux, decrease in back EMF, increase in armature current, increase in brush drop. If load on a DC shunt motor is increased, its speed is decreased due to increase in flux, decrease in back EMF, increase in armature current, increase in brush drop. The exact correct answer is decrease in back EMF. This is a formula begin this answer is EB equal to V minus IA into RA. You have to increase the load of the DC shunt motor means armature current value also increases. The IARA drop voltage also increases. The V minus IARA value means reduced means it is a decreased in back EMF value. So question number 18. If the load current and the flux of a DC motor are held constant. If a load current and flux of a DC motor are held constant and the voltage applied across its armature is increased by 10%. And the voltage applied across its armature is increased by 10%. Its speed will, option A, decreased by about 10%. Option B, remain unchanged. Option C, increased by about 10%. Option D, increased by 20%. Here, if the load current and the flux of a DC motor are held constant, if a load current and the flux of a DC motor are held constant, the voltage applied across its armature is increased by 10%. Increased by 10% of applied voltage means its speed also will increase by 10%. Okay.
வணக்கம்பா அன்பரசு
Sir, record பண்ணிட்டு இருக்கேன் sir. If the load current and the flux of a DC motor are held constant and the voltage applied across its armature is increased by 10%, its speed will increase by about 10%. Okay. So question number 19. Question number 19. If the pole flux of a DC motor approaches 0, if the pole flux of a DC motor approaches 0, its speed will approaches 0, approach infinity, no change due to corresponding change in back EMF, approach a stable value somewhere between 0 and infinity. If the pole flux of a DC motor approaches 0, its speed will approach infinity, because flux value can be reduced means automatically the motor speed can be increased infinitely. Okay, it is inversely proportional to each other. N directly proportional to E divided by flux by means the flux value, that is pole flux of a DC motor approaches to 0 means the speed of the DC motor can be increased infinitely. So that's why option B is the correct answer. The next question, 20th questions. If the field circuit of a loaded shunt motor is suddenly opened, if the field circuit of a loaded shunt motor is suddenly opened, option A, it would race to almost infinity speed. It would draw abnormally high armature current. Option C, circuit breaker or fuse will open the circuit before too much damage is done to the motor. Option D, torque developed by the motor would be reduced to 0. Torque developed by the motor would be reduced to 0. Yeah. If the field circuit of a loader shunt motor is suddenly opened, then what happened? The circuit breaker or fuse will open the circuit before too much damage is done to the motor. Here, it is the correct answer, because it is abnormally there is a fault in the field circuit means automatically the circuit breaker will be operated. So option C is correct answer. The circuit breaker or fuse will open the circuit before too much damage is done to the motor. Okay. So option C is the correct answer. Question number 21. Which of the following DC motor would be suitable for drives requiring high starting torque, but only fairly constant speed such as thrusters? Which of the following DC motor would be suitable for driving require high starting torque, but only fairly constant speed such as thrusters? So only require for high starting torque means we have to not on the series motor. But in case another option, fairly constant speed is required for the such thrusters. So we have to note on the correct answer for compound motor. So compound motor which consists of series flux and shunt flux. So both the options are there in compound motor. The correct answer is compound motor. DC compound motor is the correct answer for this question number 21. So number 22. A DC shunt motor is found suitable to drive fans because they require. The DC shunt motor is found suitable to drive fans because they require small torque at startup, large torque at high speed, practically constant voltage, both A and B. A DC shunt motor is found suitable to drive fans because they require only small torque at the time of the starting and also require for large torque at the high speed. The correct answer is both A and B. The correct answer of this question number 22, both A and B. The fan type of motor requires only low starting torque for the starting and also requires for high starting torque for high speed. So both A and B is the correct answer in question number 22. Next question number 23. Which of the following load would be best driven by a DC compound motor? Which of the following load would be best driven by a DC compound motor? Option C, it is a reciprocating pump. Which of the following load would be best driven by a DC compound motor? So DC compound motor only for the purpose of reciprocating pump. Centrifugal pump, centrifugal pump, it is the shunt motor application. Electric locomotives, it is the DC series motor applications. Fan type of load is only a shunt motor. So reciprocating pump, it is the common motor. The correct answer is reciprocating pump. So question number 24. As the load is increased, the speed of a DC shunt motor. Option A, increases proportionality, remains constant, increases slightly, reduces slightly. As the load is increased, the speed of the shunt motor, definitely it is reduces slightly. Reduces slightly only. Okay, because DC shunt motor is also known as constant speed motor. You can increase the load, only small percentage of speed is reduced. Next question number 25. Between no load and full load, dash motor develops a least torque. Between no load and full load, dash motor develops the least torque. Series motor, shunt motor, cumulative compound and differential compound. Between no load and full load, dash motor develops a least torque. Option A, it is the correct answer. Series motor. From no load to full load, the percentage of torque developed in the motor is very small. Least torque is developed. Only at the time of the starting, to produce the highest turning. The question number 26. The torque versus armature graph of a DC series motor is here. The torque versus armature current. Armature torque and armature current graph of a DC series motor is here. Option A, parabola from no load to overload. Option B, straight line throughout. Option C, parabola throughout. Option D, parabola up to full load and a straight line at overloads. So definitely option D is the correct answer. Initially, the graph is in the form of parabola up to full load condition. After full load, it is act as a DC shunt motor. This DC series motor, initially DC series motor natural graph. After full load condition, the torque versus armature current graph value is straight line. Option D is the correct answer. That means initially to produce an high starting torque. After full load, the torque versus armature current cannot be changed. Question number 27. Yes, compared to shunt and compound motors. Yes, compared to shunt and compound motors, series motor has the highest torque because of its comparatively dash at the start. Yes, compared to shunt and compound motors, series motor has the highest torque because of its comparatively dash at the start. Option A, lower armature resistance. Option B, stronger series field. Option C, fewer series turns. Option D, larger armature current. Yes, compared to shunt and compound motors, series motor has highest torque because of its comparatively at dash at the start, stronger series field. Stronger series field. Because the series field winding, armature winding connected in series with the supply. That means it produces stronger series field flux. So that's why it produces an high starting torque. Okay. IA equal to ISA equal to IL. That is the formula behind these questions. The question number 28. Unlike a shunt motor, it is difficult for a DC series motor to stall under a heavy loading because unlike a shunt motor, it is difficult for a series motor to stall under a heavy loading because option A, it develops high overload torque. Option B, it flux remains constant. Option C, it slows down considerably. Option D, it back EMF is reduced to almost zero. The back EMF is reduced to almost zero. Unlike a shunt motor, it is difficult for a series motor to stall under heavy loading because it develops high overload torque. Because it develops high overload torque. This is the correct answer for question number 28. Because field flux remains constant, it is not correct answer for the DC series motor. It slows down considerably, it is not correct answer. Back EMF is reduced to almost zero, so it is not correct answer. The exact answer is it develops a high overload torque. Question number 29. When load is removed, when the load is removed, dash motor will run at highest speed. When the load is removed, dash motor will run at highest speed. Shunt motor, cumulative common motor, differential common motor, series motor. So definitely it is a DC series motor. Always the DC series motor starts with some mechanical load. So due to the speed of the DC motor is inversely proportional to the flux of a DC series motor. Initially, we have to increase the flux value means we have to reduce the speed of the DC motor. Okay. In this question, the option D is the correct answer. Question number 30. A series motor is best suited for driving. Option A, lathes. Option B, cranes and hoist. Option C, shears and punches. Option D, machine tools. The exact correct answer is crane and hoist. It is one of the applications of DC series motor. So question number 31. A 220 voltage shunt motor develops a torque of 54 Newton meter at armature current of 10 ampere. A 220 voltage shunt motor develops a torque of 54 Newton meter at armature current of 10 ampere. The torque produced when the armature current is 20 ampere is option A 54 Newton meter, option B 81 Newton meter, option C 108 Newton meter, option D none of the above. The available data is 220 voltage shunt motor develops a torque of 54 Newton meter at armature current of 10 ampere. The torque produced when the armature current is 20 ampere is 108 Newton meter. The formula of torque is directly proportional to flux pi into Ia. This torque Ia equal to Ta equal to 1 by 2 pi plus pi into Ia into P by A. So 108 Newton meter is correct answer. Because torque is directly proportional to pi into Ia. We can increase the armature current value Ia into 20 ampere, 10 ampere into 20 ampere. Also Newton meter torque also doubled. So for 108 Newton meter. So question number 32. The DC series motor should never be switched on at no load because the DC series motor should never be switched on at no load because option A field current is 0. The machine does not pick up. The speed becomes dangerously high. It will take too long to accelerate. Definitely question number 32. The correct answer is the speed becomes dangerously high. This is the correct answer. Already we know that n directly proportional to 1 by flux pi. Initially there is no field current means flux value is also very low. It will run at dangerously high. We can avoid the dangerous speed. We can never be switched on at no load conditions. Only one of the reason is the speed becomes dangerously high. Next question number 33. A shunt DC motor works on AC machines. A shunt DC motor works on AC means alternating current. Option A satisfactorily, not at all, none of the above. It is unsatisfactory. Never DC shunt motor can be operated on AC supply. The only option is DC series motor can be switched on for the AC also. So that is called as an AC series motor. So question number 34. A 200 voltage 10 ampere motor would be rewound for a 100 volt 20 ampere by using dash S but it turns per coil of wire having dash cross sectional area twice and by using twice or half the cross sectional area, thrice or 1/3 of cross sectional area, half or twice the cross sectional area. Option D 4 times and 1/4 of the cross sectional area. We have to reduce the voltage means half. current you have to increase the twice. So option C is the correct answer. Okay. Yeah, 200 voltage it can be reduced by 100 voltage. That is half of the voltage. 10 ampere can be increased by twice, 20 ampere. So option C is the correct answer. Next, transformer objective type questions. A transformer transform frequency, voltage, current, voltage and current. A transformer transform option A frequency, option B voltage, option C current, option D voltage and current. Definitely voltage and current is the correct answer. The transformer transform both voltage and current. That means it is to convey electrical power in one circuit to another circuit. Which of the following is not a basic element of a transformer? Which of the following is not a basic element of a transformer? Core, primary winding, secondary winding, mutual flux. The core, primary winding, secondary winding, it is the one of the element of the transformer. The mutual flux, it is the unknown data. It is the imaginary flux lines. It is not depends not in the element part. Okay. So option D is the correct answer. In an ideal transformer, winding have no resistance, core has no losses, core has infinite permeability, all of the above. The ideal transformer which has the following properties: the winding have no resistance, the core has no losses, the core which has infinite permeability. The correct answer is all of the above. All of the above is the correct answer. So question number 4, the main purpose of using core in a transformer is to, the main purpose of using core in a transformer is to decrease iron losses or prevent eddy current losses, eliminate magnetic hysteresis, decrease reluctance of the common magnetic circuits. So main purpose of using core in the transformer is to decrease reluctance of the common magnetic circuits. It is the correct answer. Okay. The transformer cores are laminated in order to simplify its construction, minimize eddy current losses, reduce cost, reduce hysteresis losses. The transformer cores are laminated in order to simplify its construction, minimize eddy current losses, reduce cost, reduce hysteresis losses. The minimize eddy current losses is the correct answer. Yes, the purpose of lamination is it is used to reduce the eddy current losses. A transformer having 1000 primary turns is connected to a 250 voltage AC supply. For a secondary voltage of 400 voltage, the number of secondary turns should be 1600, 250, 400, 1250. Okay, that is a formula begin N2 by N1 equal to V2 by V1. Unknown data is N2. So N2 by N1 equal to V2 by V1. So N2 equal to V2 by V1 into N1. We can calculate the correct answer is 1600. Question number 7. The primary and secondary induced EMF. The primary and secondary induced EMF E1 and E2 in a two-winding transformer are always the primary and secondary induced EMF E1 and E2 in a two-winding transformers are always option A equal in magnitude, anti-phase with each other, in phase with each other, determined by load on a transformer secondary. the primary and the secondary induced EMF E1 and E2 always in phase with each other. So already we know that the by means of drawing the no load phasor diagram, E1 and E2 both are in same vector diagram. Okay? Always in phase with each other. The EMF equation of E1 equal to EMF equation of E2. So both are in phase with each other. Question number 8. A step-up transformer increases. A step-up transformer increases. Option A, voltage, current, power, frequency. So step-up transformer increases voltage, current, power, and frequency. So definitely it is a step-up transformer increases the voltage only. That is the voltage. Option A is the correct answer. The step-up transformer increases only the voltage. Question number 9. The primary and the secondary winding of a ordinary two-winding transformer always have the primary and the secondary winding of an ordinary two-winding transformer always have different number of times same size of copper wire, a common magnetic circuit, separate magnetic circuits. So question number 9. The primary and secondary winding of a ordinary two-winding transformer always have common magnetic circuit. Common magnetic circuit. The magnetic flux flow through the primary winding and the secondary winding both are same. So question number 9, option C is the correct answer. Question number 10. In a transformer, the leakage flux of each winding is proportional to the current in that winding because in a transformer, the leakage flux of each winding is proportional to the current in that winding because Ohm's law applies to the magnetic circuit. Leakage paths do not saturate. Two windings are electrically isolated. Mutual flux is confined to the core. In a transformer, leakage flux of each winding is proportional to the current in that winding because leakage paths do not saturate. This is the correct answer. In a two-winding transformer, the EMF per turn in a secondary winding is always the induced EMF per power in primary. In a two-winding transformer, the EMF per turn in secondary winding is always dash the induced EMF power turn in primary equal to K times equal to 1 by K times equal to or greater than. Always equal to. Already we will discuss the EMF equation of transformer E1 equal to EMF equation of secondary winding E1 equal to E2. In relation to a transformer, the ratio of 20:1 indicates that there are 20 turns on primary, 1 turn on secondary. Secondary voltage is 1 by 20th of primary voltage. Primary current is 20 times greater than the secondary current. For every 20 turns on primary, there is 1 turns on secondary. It is the last option is correct answer. Every 20 turns on primary, there is 1 turn on secondary winding. Question number 13. In performing the short circuit test of a transformer, option A, high voltage side is usually short circuited, low voltage side is usually short circuited, any side is short circuited with preference, none of the above. So definitely C and D is not correct answer. Only we have to conclude for the A and B. So mostly short circuit test we conducted for the low voltage side is usually short circuited because it is used to measure the current, high current in the winding. So option B is the correct answer. Low voltage side is usually short circuited. 14, question number 14. The equivalent resistance of a primary of a transformer. The equivalent resistance of the primary of a transformer having K equal to 5 and R equal to 0.1 ohm when referred to secondary because dash ohm. The equivalent resistance of a primary of a transformer having K equal to 5, R1 equal to 0.1 ohm when referred to secondary becomes dash ohm. It is a 2.5 ohm. The transformer has negative voltage regulation when its load power factor is. The transformer has negative voltage regulation when its load power factor is 0, unity, leading and lagging. So mostly the negative voltage regulation of the transformer only that depends upon the leading power factor. The capacity load. The transformer is connected across the capacity load means they give the leading power factor and also they gives the negative voltage regulation. Question number 16. The primary reason why open circuit test is performed on low voltage winding of the transformer is that to draw sufficiently large load current for the convenience reading, to requires least voltage to perform the test, it needs minimum power input, involves less core losses. The question number 16. To draw sufficiently large load current for the convenience reading. It is the correct answer. Question number 17. No load test on a transformer is carried out to determine. No load test on a transformer is carried out to determine option A copper losses, magnetizing current and no load losses, efficiency of a transformer. Definitely it is used to determine no load losses and also used to determine the magnetizing current. The no load test of a transformer is carried out to determine magnetizing current and also no load losses. Question number 18. The main purpose of performing open circuit test on a transformer is to measure its copper losses, core losses, total losses, insulation, resistance. So definitely it is the core losses. The main purpose of performing open circuit test. Open circuit test is used to determine the core losses. Short circuit test is used to determine the copper losses. Here the question number 18, the core losses is the correct answer. Question number 19, during short circuit test, the IR losses of a transformer is negligible because the entire input is just sufficient to meet copper losses only. The flux produced is a small fraction of the normal flux. The iron core becomes fully saturated. Supply frequency is held constant. The option B is the correct answer. The flux produced is a small fraction of the normal flux during the short circuit test. Question number 20. The IR losses of a transformer at 400 Hz is 10 watts, assuming that eddy current and hysteresis losses vary as the square of the flux density. The IR losses of the transformer at rated voltage, but 50 Hz would be dash watt. This correct answer is 640 watts. You can use for the formula and put out the answer. 640 watts is the correct answer. In operating a 400 Hz transformer at 50 Hz, transformer at 50 Hz, only voltage is reduced in the same proportional as the frequency. Only kVA rating is reduced in the same proportion as the frequency. Both voltage and kVA rating are reduced in the same proportion as the frequency. None of the above. Here option B is the correct answer. Only kVA rating is reduced in the same proportion as the frequency. Next question number 22. The voltage supplied to the high voltage side of a transformer during short circuit test is 2% of its rated voltage. The core losses will be dash percentage of the rated core losses. 0.04%. Here 0.04%. The transformers are rated in kVA instead of kilowatt. The transformers are rated in kVA instead of kilowatt because load factor is often not known. kVA is fixed whereas kW depends upon the load factor. Total transformer losses depends upon only voltage and ampere. Total transformer loss depends upon voltage and ampere. It just becomes customary. So correct answer is total transformer losses depends upon only the voltage and the current. This is the correct answer. When a 400 hertz transformer is operated 50 hertz, its kVA rating is 24 is reduced to 1 by 8. Question number 25. At relatively light loads, the transformer efficiency is low because at relatively light loads, transformer efficiency is low because secondary output is low, transformer losses are high, fixed losses is high in proportion to the output, copper losses is small. At relatively light loads, transformer efficiency is low because fixed losses is high in proportion to the output. Okay, it is the correct answer because at light load condition, the transformer efficiency is low only due to fixed output. A 200 kVA transformer has iron losses of 1 kilowatt and full load copper losses of 2 kilowatt. Its load kVA corresponding to the maximum efficiency is dash kVA. It is one of the formula available. By using this formula, we can determine the answer. 141.3. Okay. 141.4 kVA is maximum efficiency. Under maximum efficiency, we have to determine for the x value. Square root of Pi by PCU. That is a formula beginning the question number 26. If copper losses of a transformer at 7 by 8 full load is 4900 watts and its full load copper losses would be dash watts. So question number 27 is the correct answer is 6400 watts. You can check the correct answer. 6400 watts full load copper losses. Ordinary efficiency of a given transformer is maximum when. So definitely the copper loss is equal to iron losses. Definitely the copper losses equals to iron losses. So that is the conditions for maximum efficiency. The output current corresponding to the maximum efficiency of a transformer having core losses of 100 watts and equivalent resistance referred to the secondary of 0.25 ohm is dash ampere. Already knowing that what power watt is and also resistance value is also there. You can determine by using this formula. The correct answer is 20 ampere. The maximum efficiency of a 100 kVA transformer having high losses of 900 kilowatts and full load copper losses of 1600 watts occurs at dash kVA. The exact correct answer is 75 kVA. All-day efficiency of a transformer depends primarily on its copper losses, amount of load, duration of the load, both B and D. So definitely both B and C. It is the correct answer because all-day efficiency of a transformer depends upon the total amount of the load and also duration of the load. The marked increase in kVA capacity produced by connecting a two-winding transformer as an auto transformer is due to increase in turns ratio, increase in secondary voltage, increase in transformer efficiency, establishment of conductive link between primary and secondary. It is option D is the correct answer. Establishment of conductive link between primary and secondary. The kVA rating of a ordinary two-winding transformer is increased when connected as an auto transformer because transformation ratio is increased, secondary winding voltage is increased, energy is transferred both inductively and conductively, secondary current is increased. The energy transfer both inductively and conductively. That is the correct answer. The kVA rating of the ordinary two-winding transformer is increased when connected as an auto transformer. The energy is transferred both conductively and conductively. The saving in copper achieved by converting a two-winding transformer into auto transformer. It is determined by voltage transformation ratio, load on the secondary, magnetic quality of the core material, size of the core. So voltage transformation ratio is the correct answer for the number 30. The saving of copper mostly depends upon the voltage transformation ratio. The auto transformer having a transformation ratio of 0.8 supplies load of 3 kilowatt. The power transferred conductively from primary to secondary is dash kilowatt. The 2.4 kilowatt. Auto transformer having transformation ratio of 0.8 supplies a load of 3 kilowatt. The power transfer conductively from primary to secondary. It is multiplied by 3 kilowatt. Okay, so that is the answer. B is the correct answer. 2.4 kilowatt. The essential conditions for parallel operation of two single-phase transformers is that they should have the same option A polarity, kVA rating, voltage ratio, percentage impedance. The essential condition is polarity is the essential condition. It is the main point to parallel operation of two single-phase transformer. So polarity must be same. Here, question number 37. If the impedance triangles of two transformers operating in parallel are not identical in shape and size, the two transformers will share the load unequally, get heated unequally, have a circulatory secondary current even when unloaded, run with different power factor. So run with different power factor. That is the correct answer. Then, if the two impedance triangle of a two transformer operating in parallel, not identical in shape and size, and the two transformer will run with different power factor. Two transformers A and B having equal outputs and voltage ratio but unequal percentage impedance of 4 and 2 are operating in parallel. The transformer A will be running overload by percentage. Option A 50, 66, 33 and 25. That answer is 33. Okay. Okay. This class we have discussed about the various multiple choice questions about the electrical machines. Topic behind the DC motors, transformers, single phase transformers only. The next class we have to discuss about the three phase transformer objective type questions. Okay, thank you.